Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. I hope you are all doing well and safe. So, not to be wasting our time, our group will be present on topic application of differentiation. But before that, what is differentiation? Differentiation is the process of determining a function's derivative or rate of change is known as differentiation in mathematics, in contrast to the abstract character of the theory that underpins it. Differentiation may be accomplished using just algebraic operations, requiring only three fundamental derivatives, follows of operation, and a working understanding of functions. Next is differentiation and derivatives. Differentiation is basically the process of computing a derivative. Meanwhile, a derivative is a measure of how quickly the value of a function changes in response to a change in the variable used to compute the derivative. So, what is the use of differentiation? We can use differentiation to discover change rates. For instance, it enables us to determine the rate of change of velocity with respect to time, which is acceleration. It also allows us to calculate the rate of change of x with respect to y, which is the gradient of the curve on a graph of y versus x. Differentiation may assist us in resolving a wide range of real-life issues such as determining the concavity, curve sketching, and optimization. And we can use the derivative to determine the maximum and minimum values of particular functions. For example, cost, strength, amount of material used in building, profit, loss, and etc.
So we're going to continue with the first problem statement and solution statement related. So this is the problem statement. A 3-meter ladder is leaning against a wall. If the bottom of the ladder is being pulled away from the wall at a rate of 0.4 meter per second, how fast is the angle between the top of the ladder and the wall changing when the angle is pi/2 rate? So here, this is the diagram for the question so that we can have a better understanding. From the question, it states that the length of the ladder, which is this one, is 3 meter, and then this ladder is being pulled away from the wall, which is the ladder is going to the right, and the rate is 0.4 meter per second, which is we can label it as dg over dt. Why g? Because it's on the ground, which is a distance between wall and the bottom of the ladder. Next, in the question also state that the angle between wall and the top of the ladder is pi/2 rate. The question asks us to find the angle changing between top of the ladder and the wall. So how we want to find it? We're going to continue with the next slide. This is the solution statement, and all of these are the information given. So we have dg over dt, which is 0.4, d theta over dt, which is we need to find the value, and then theta equal to pi/3. So how we want to find the value of d theta over dt? So for the first step, we need to find the value of g by using this formula, which is sin theta equal to g/3. How we get this formula? We need to look back at the diagram. So we know that sin equal to O divided by H, which is the value of H is 3 and the value of O is G. So we just need to submit the information given, and then 3 will be going to the left side and it will be 3 sin theta equal to G. After that, we need to differentiate the G and it will be dg over d theta equal to 3 cos theta. For the step 2, we know that the question asks us to find the d theta over dt. We already have the information about dg over dt and also dg over d theta. So we can use the information dg over dt here, and then for the dg over d theta, we need to rearrange back the data, which is d theta will going up and the dg will going down. So it will be d theta over dg times with dg over dt. So that we can cancel both of the dg and both of them will be combined and form d theta over dt. For the value of d theta over dt, it will be 1/3 cos theta and then times with 0.4 and then we get 0.4/3 cos theta. This is not the last answer because we need to find the value of d theta over dt. So for the step 3, we need to submit the value of theta given, which is pi/3, and then we calculate the answer using calculator, and then the final answer it will be 4/15 rate per second.
Assalamualaikum and selamat sejahtera. My name is Arina Alia. We will highlight problem statement 2. A wire of length 100 cm is cut into pieces I1 and I2. I1 is bent into a circle and I2 into a square. Determine I1 and I2 so that the total area of the circle and square is a minimum. This problem can be determined by following steps. Step A. Compare parameter to given length. Parameter I1 and parameter I2 will be added equal to 100. By formula parameter of circle added to parameter of square. This will make 2 pi r plus 4x equal to 100. Pi r plus 2x equal to 50 and x will be 50 minus pi r divided by 2. Total area will be pi r power of 2 plus x power of 2, which x is 50 minus pi r divided by 2. Next step, compare derivative of area dA slash dr equal to 0 because it's minimum. So, total area then will be expand to the derivative of area 2 pi r plus 2 bracket 50 minus pi r divided by 2 minus pi per 2 equal to 0. 2r minus 25 plus pi r per 2 equal to 0. R equal to 25 divided by 2 plus pi per 2. R equal to 7 cm. Final step, find second derivative and replace the value of r. As we know, dA dr equal to pi r power of 2 plus 50 minus pi r divided by 2 power of 2. Then we'll be expand to second derivative d power of 2a dr power of 2 equal to 2 pi plus pi power of 2 per 2. When r equal to 7 and second derivative equal to positive value, I1 equal to 2 pi. With r replaced by 7, will be total 44 cm. I2 then equal to 100 minus by I1 44 cm equal to 56 cm. That's it, thank you.
Okay, we go through the conclusion. With integration and differentiation as mathematical techniques, we have been able to reach the solution of the different methods used. Each of the methods bring a simple and clear way, thus can be used for practical data. Furthermore, with tables and figures, we have been able to compare the actual data with the predicted data. The analyzing of the different countries that are less developed has given an overview of how overpopulation will cause several problems. For example, instability, showing the country's development, the viscous poverty circle, pollution, and environmental degradation. Using the technique above, we have been able to predict population sizes with and without family planning. For example, we analyzed the family planning policy in China, evaluated how it has advantageously helped China in its development and poverty reduction. Therefore, it will be true if we say that other developing and underdeveloped countries deserve to emphasize on the implementation of the family planning rule in order to reduce the negative impacts of massive population that has affected our world. This project can therefore be viewed as a scientific effort to measure and manage population growth in the current world setup. It can also help struggling or developing nations adapt some of the method. displayed above to improve their social and economic status.